Hi, Assalamualaikum warahmatullahi wabarakatuh, and good morning. So, how are all of you today? Now, we're in the topic of lecture 2 of 3 for subtopic of 1.3 indices and search. We are still in chapter 1. So, now for this topic, we're going to look into the content of. Okay, let's take a look at the learning outcome. Okay, you have your handout with you right now. So, please refer to your handout. At the end of lessons, you'll be able to express the rules of indices. So what is indices here? Index, or maybe something we call indices. The definition for all a element of real numbers and n is always positive integer. Okay, so it's just like with a multiplied with a multiplied with a, and a few times of multiplication of a, then when n factors of a equal to a to the power of n. A to the power of n. So a is what we call a base, and n exponent or power index, and a to the power of n an exponential expression. So definition 2, for all a element of real numbers and n is a positive integer. So look at this one here now. A to the power of n, which is a multiplied with a multiplied everything here. A to the power of 0 equal to 1, and a cannot be equal to 0 because it's under become 0 to the power of 0. And also a to the power of negative n equal to 1 over. So we have a negative, so it becomes equal 1 over a to the power of n. Okay, negative index. If a is a real numbers and m and n are integers, for which that square root of a nth root of a is real, then a to the power of m divided by n, m over n equal to nth root of a to the power of m. Okay, or maybe something like this one here. Ratio index, and look at all these properties here, and this is the one that we're going to use all the rules to solve the question of indices. So rules here for this one is just like 2 square multiplied with 2 cube. That is 2 plus 3 equal to 2 to the power of 5. And what about this one here now? Let's say 2 power of 7 divided by 2 to the power of 4. And we come up with 2 power of 7 minus 4 equal to 2 cube. Okay. And one of a simple example of this one here. Okay, so a to the power of m in bracket to the power of n. So we multiply between these two index, m times n, and also here n, okay, a to the power of n, and also b to the power of n. Yes, same goes with this one here now. Okay, so using your calculator, let's find out this one here now. It's just like 9 power of negative 3 over 2. 9 is 9 itself is 3 squared. Then power of negative 3 over 2. So 2 times negative 3 over 2, cancel between this one here, and it gives you 3 power of negative 3. 3 power of negative, okay, it is 1 over 3 cube, which is 1 over 27. So what about this one here now? Okay, so for this 1 over 25, is 1 over 5 squared, power of negative 3 over 2. And bring this above here, it becomes 5 power of negative 2, power of negative 3 over 2. Negative times negative positive, so 2 divided by 2 here. Then what's left here now? So 5 to the power of 3, which is 125. Okay, as simple as that. That's the beginning of our discussion for this morning. So express this in the simplest form. Okay, class, what do you think? 18 divided by 3 equal to 6. X squared divided by x to the power of 4. Just imagine that we have x power of or x squared divide, so you come up with minus 4. 2, 4 here, 2 minus 4, and y 5 divide, so we come up with minus 1. So 6x 2 minus 4 is negative 2, y equal to 4, or it is a 6y power 4 divided by x squared. And this one here now. Okay, so 3, and we change 9 into the base of 3, and also 27 to the base of 3. 3 power of n plus 2 multiplied with 9 itself is a 3 squared. 3 squared times n here, and divide by 27 is 3 cubed. 27 itself is a 3 cubed and multiplied with an n of 3n. So now 3n plus 2 multiplication multiplied, so plus with 2n, and divide means that is minus of 3n, n plus 2n equal to 3n, and minus 3n equal to 0. So what's left here now, which is 2. So 3 squared equal to 9. So we continue. So this is a simple example how to solve the question of indices. So the solution of this one here now. Okay. Okay, for surd, in other words, we call it as a square root. Surd is some this notation as a surd or square root. Square root, or might be nth root, something like that. Okay. Explain the meaning of a surd and its conjugate, and perform algebraic operation on surds. So surd is an irrational numbers in which form of n root of a, where n is a element of real numbers, n is a here, and also is a element of which is expressed in the term of root signs. Irrational numbers which are surds, okay, square root of 2, square root of 7, and cube root of 5. Square root of 2, square root of 7, cube root of 5. So square root of 9 is known as a surd? No, because 3 is not an irrational number. So rules of surds, okay, please refer to this one here. Square root of a times square root of b equal to square root of a times b. And same thing with this one here. And also A and B are positive real numbers. Okay, please, caution here. Square root of B times square root of B equal to square root of A times B. Okay, square root of 2 times square root of 5, which is equal to square root of 10. But then, negative square root of 2 times square root of 5, which is not equal to 10. A and B are positive real numbers. So for positive real numbers only, does not include with a negative. And also for this one here, okay, okay, so square in bracket square root of A plus square root of B square, we cannot simply put a square root for each of these, just like this one here. We are going to expand it, meaning that this term, the term in the bracket, will appear twice. Okay. Example 1, simplify every single of this. Okay, so for the first one then, what about this? Okay, so it's just we call additional between this, okay, between these two, the term inside these two bracket. So it's just like 2 square root of 3 minus 5 square root of 2 plus 7 square root of 3 plus positive with positive 2 square root of 2. That's all. Okay, so square root of 3 with square root of 3, so 2 plus 7 equal to 9 square root of 3, and then square root of 2 and square root of 2. Negative 5 plus 2 minus 3 square root of 2. Next one. Okay, but for the sign of positive or additional here, we don't have to worry much, because positive, if multiplied with positive or negative, it won't change the sign inside. But for negative, please be careful. Okay, now let's try with the 5 square root of 7 plus 3 square root of 5, negative times positive, negative 8 square root of 7, negative times negative, positive square root of 5. Okay, now square root of 7 and square root of 7, 5 minus 8, negative 3 square root of 7, and square root of 5 with square root of 5, 3 plus 1 equal to 4 square root of 5. For question C, okay, now to simplify this, we are going to multiply this one square root of 3 with every single term that we have on the other bracket, and also square root of 2 times with this one and 2 times this. So then square root of 3 times 2 square root of 3. Okay, 2 with 1, 2. Square root of 3 times square root of 3, 3. Okay. Square root of 3 times square root of 2 plus with square root of 2 times with square root of 3. So for square root of 3 is complete multiplied with every single term that we have in the other bracket. So now it's for square root of 2. Square root of 2 times square root of 3, and 2 here we have 2 square root of 2 square root of 3, and then square root of 2 times square root of 2 equal to 2. So then 2 times 3 equal to 6. So 6 plus 2 equal to and 8 plus. Okay, for this one here, we can just simply write down as square root of 2 times square root of 3, or you may change it into square root of 6, either one. But then look at this one here now. 1 plus 2 equal to 3 square root of 2 square root of 3. Okay, so again, guys, girls, 3 square root of 3 minus 5 square root of 2 square. So meaning of this square, which means that 3 square root of 3 minus 5 square root of 2, it appears twice. So we have another 3 square root of 3 minus 5 square root of 2. So for this one here, 3 square root of 3 times 3 square root of 3, 3 times 3 equal to 9. Square root of 3 times square root of 3, 3. And this one here, this multiplied with this one, 3 times 5 equal to 3 with negative minus 15. Square root of 3, square root of 2, square root of 3, negative 5, square root of 2 times this one here, minus 15, square root of 2, square root of 3, and negative 5 with negative 5, plus 25, square root of 2 times square root of 2, equal to 2. So 9 times 3 equal to 27. Negative 15, 2 set 2 with a set 3, and so on, minus 30 square root of 2 square root of 3. 25 plus times 2 equal to 50. So 50 plus 27, 57 minus 30 square root of 2 square root of 3. Okay, class, I think that I make a simple mistake here. 50 plus 27 is supposedly 77. Okay, I'm sorry for that. So example 2, simplify the following. Square root of 8. We are going to use these rules. Square root of A times B, which is equal to square root of A multiplied with square root of B. So how are we going to use this in this question here? 8 is, okay, result of 8, which is from 4 multiplied with 2. Then come up with square root of 4 times square root of 2, where square root of 4 equal to 2. So 2 square root of 2. Next, what about this one here now? Which is 5 square root of 3 minus 27, which is 9 times 3. So then 5 square root of 3, square root of 9 equal to 3 with square root of 3. So then you come 5 minus 3 equal to 2 square root of 3. Okay, so we have this one here now. 12 square root of 2 plus with 3. Okay, so for 72, we make this one as a square root of 36 multiplied with 2. Then we have 12 square root of 2 plus with 3. Okay, for this equal to square root of 36 multiplied with square root of 2 and square root of 36, which is equal to 6 square root of 2. So then we have here 6 and square root of 2. So 12 square root of 2 plus with 3, 6 is 18 square root of 2. Then we have here, what you have here is now 30 times square root of 2. Rationalizing the denominator when square root occurs in quotients. When the square root occur in quotients, okay, it's customary to rewrite the quotient so that the denominator contains no square roots. And in rationalizing the denominator of a quotient, be sure to multiply both the numerator and denominator by the same expression. Okay. Okay, right here, A is numerator and B is denominator. So the choice of multiply is by no means accidental. When more complicated expression need rationalizing, the multiply is simply the conjugate of the original denominator. Okay, so square root of A minus square root of B equal to square root of A plus square root of B. The changing we call the sign from negative to positive here, and also from positive to negative. Expression are conjugates of one another. So look at this one here now. This is square root of A plus square root of B, and this is the conjugate of the expression of this. So once we multiply the expression, this one here, with the its conjugate, finally is only A minus B, where this one here, the sign observes cancelling between these two because it minus by itself. Okay, so that is the one that we're going to use. Rationalize the following. What about this one here now? Okay, so for single term like this, okay, so then for question A, 14 divided by square root of 7, and for this one we just come up with square root of 7 divided by square root of 7 because you only have one expression here. So square root of 7 times square root of 7 equal to 7, and 14 square root of 7, where 14 is, okay, 14 divided by 7 equal to 2. So it is equal to times square root of 7. Question B, square root of 1 over 7 minus square root of 2. So we multiply with 7 plus square root of 2, and also denominator here with 7 plus square root of 2. Okay, so for this one here now, 1 multiplied with 7 and also square root of 2, we just copy it all again. 7 plus square root of 2, 7 times 7, 49. 7 times square root of 2 is positive 7 square root of 2. Negative this one here, multiply with 7, come up with negative 7 square root of 2. So cancelling each other. Okay, it's okay. I write down 7 times this one plus 7 square root of 2. And this negative one multiplied with this minus 7 square root of 2. and negative times positive, negative, square root of 2 times square root of 2 equal to 2. So then, cancel these two. So 749 minus 2 equal to 47 plus with square root of 2 divided by 47, or we just write down as 7 plus square root of 2 divided by 47. What about question C? Question C, square root of 2 plus 3 divided by square root of 2 plus 1. Okay, so our reference now here is at a denominator. Okay, so we come up with square root of 2 minus 1 divided by square root of 2 minus 1. Okay, so square root of 2 times square root of 2, 2, this with this one minus square root of 2 plus with 3 times square root of 2, 3 times negative 1 minus 3 divided by, okay, square root of 2 times square root of 2, 2. With positive negative, negative cancelling each other, so 2 minus 1 equal to 1. Okay, so finally come out with 2 minus 3 equal to negative 1, and then 3 minus 1 equal to 2 square root of 2. Okay, so for question D, so look at this one here, class. For this one, if I make it like this, okay, 1 plus square root of 2 divided by 1 minus square root of 2 plus with 1 minus square root of 2 divided by 1 plus square root of 2. Okay, so I designed the question here. Look at these two, 1 minus square root of 2 and 1 plus square root of 2. So we consider this one as 1 plus square root of 2 is a conjugate to the expression of 1 minus square root of 2. So it's just like if I came out here with, okay, for this one, then come up with 1 plus square root of 2. Then we also have 1 plus square root of 2. And what about this one here now? Opposite of this is 1 minus square root of 2 and 1 minus square root of 2. So you can see here now 1 plus square root of 2 multiplied with 1 plus square root of 2, and this multiplied with this conjugate. Okay, so 1 plus times 1 equal to 1, and then 1 times this square root of 2 and another square root of 2, it come up with 2 square root of 2 plus with square root of 2 times square root of 2 equal to 2. Okay, 1 minus square root of 2 multiplied with 1 plus square root of 2, 1 plus square root of 2 multiplied with 1 minus square root of 2, which I think that for both of denominator, for this one and this, it will give you the same denominator, okay, the result of denominator, because actually that for both is a conjugate to each other. So 1 times 1, there you go, and then square root of times square root of 2 positive, square root of 2 negative, cancel each other, so then negative multiplied with the positive, negative, square root of 2 times square root of 2, 2. Okay, so then plus, and the result of this, 1 times 1 equal to 1. 1 times this, square root of 2, another square root of 2, minus 2, square root of 2, and negative times negative, positive square root of 2 times square root of 2 equal to 2. Okay, and then look at this one here now. Positive 2 square root of 2, negative 2 square root of 2. Okay, so then 1 plus 2 equal to 3, plus 1 equal to 4, plus 2 equal to 6. 1 minus 2 equal to negative 1, or it's equal to negative 6. Okay, so then next, rules of third, and this one here. Oh, that's all. Thank you very much for your time. Until we meet again in the next session of our class, thank you very much. Assalamualaikum warahmatullahi wabarakatuh, and have a nice day.